Welcome to Workplace Math 11. This is Module 1, Part 3 on slope. And the first example is on page 3. Scroll down to page 3. Okay, so what is slope? Slope is a measure of how steeply something is slanted, and it can be written as a fraction or as a decimal. So examples of slope: steepness of a roof or a mountain. And words that we use to describe slope can be the steepness, the incline, grade, and pitch. And some of those words are used in particular contexts, as we'll see when we get to the word problems. The slope ratio. The slope is actually a ratio that compares the change in a vertical distance. Vertical is up and down like this, to the change in a horizontal distance going across like this. Think horizon. You know, when you look out over the water, the horizon's nice and flat. That's horizontal. The change in the vertical distance is called the rise. The change in the horizontal distance is called the run. And the variable m is always used to represent slope. So slope m equals rise over run. Let's do an example. Calculate the slope of a line that has a rise of 12 centimeters for a run of 8 centimeters. So we have our formula that m equals rise over run. So this equals, the rise is 12 centimeters and the run is 8 centimeters. It's really important that these are the same units. Those always have to be the same units. And then we reduce our fraction. 12 over 8 reduces to 3 over 2. And we can write it as a decimal as 1.5, which is 3 divided by 2 if you need to use your calculator for that. So there's our answer. Okay. Note that slope itself has no units. Okay, there's a couple of practice questions for you to do, so pause the video and do those and then come back. Welcome back. We're now on page 2 of the notes, and hopefully you not only did those practice questions but checked your answers, because that's really important that you make sure you're getting them right as you go. You don't want to practice it wrong 50 times. In this example, we're given the slope and asked to figure out the rise. We're going to do the same thing. We're going to write our formula m equals rise over run, and we know that m is 7 over 20, and we know that the run is 100. So what is our rise? We've got a proportion here, right? We like proportions. They're easy to solve. X equals 7 times 100 divided by 20. So X equals 35 meters. Okay, we need to include the units. Oops. Include units. Okay, next example. Slope of a hill is 3 over 190. The hill has a rise of 400 meters. What is the horizontal distance covered by the hill? Let's write out our formula. M equals rise over run. Our slope is 3 over 190. We know that our rise is 400 and our run we don't know. So X equals 190 times 400 divided by 3. So our calculator tells us that X equals 25,433 meters. All right, pause the video, go do the assignment, and come on back. Okay, part C, slope and the tangent ratio. The slope is equal to the ratio of the rise over run. Oh, sorry, of rise to run. And the tangent of angle y is the ratio. Remember tan, SOHCAHTOA, right? So TOA, or some people write it as TOA, which I think is better, but is really hard for me to do because I learned it the top way. The tangent of y is the ratio of the opposite side over the adjacent side. If we look at our diagram here where we have angle y, this is our hypotenuse, here's our opposite, here's our adjacent. So our opposite is y, lowercase y, and our adjacent is lowercase x. That is exactly the same as the tangent of y being the rise over the run. So in the triangle above, the slope of the hypotenuse is the ratio of the rise, y, to the run, x. And the slope of segment z, the hypotenuse of the triangle, is the same as the tangent of angle y, which I didn't know until I started teaching AW11 math, which is crazy. Let's do an example. Find the slope of the hypotenuse as a decimal and use it to find the angle of elevation. So step 1, find slope of the hypotenuse. So we know that slope equals rise over run, and the rise on this is 6.8 over 4.2. My calculator tells me that that's 1.619. And then part 2 is find the angle of elevation. So find theta. Theta is a Greek letter that we use to denote an angle that we don't know. It's a variable. We just use it specifically for the size of an angle, not the location of an angle, but actually its size. Okay, so we want to find that. So looking at our triangle here, this is our angle of interest. Here's our hypotenuse. Here's our opposite. Here's our adjacent. Tan of theta is opposite over adjacent. Tan theta is also the rise over the run, which is the slope, which we know from above is 1.619. And then to find the angle, what we do is we take the inverse tan of both sides. So we go tan to the minus 1 of tan theta. And we do tan to the minus 1 of 1.619. So over here, this is just theta, and this is tan to the minus 1 of 1.619. I just wrote out that in full because that's how I do it when I'm teaching it. You wouldn't probably write this line out once you've learned stuff, once you've learned it and then remembered it, because this, you might be rusty on this, depends how long ago you did all of this. Anyway, we use our calculator, we use the inverse tan button, and we get theta equals 58 degrees. Actually, that's going to be the end of this video. Part D is on a separate video, so go do your homework. Bye.